We explore to discover. First, we explored the land and sea, then the skies and space, and now other planets. NASA's journey to Mars enables us to learn about the formation and evolution of the red planet. Given its similarities to Earth, Mars is also helping us learn about our own planet's history and future. Further exploration may reveal evidence of life on Mars, answering one of our oldest questions. Is there life beyond Earth? The journey to Mars is aided by past NASA discoveries and missions, which have expanded our understanding of the solar system. One tool that led to a vast array of discoveries is the Hubble Space Telescope, one of the greatest technological achievements in our history. For 25 years, the Hubble Space Telescope has orbited 375 miles above Earth, capturing images of deep space. Images from Hubble have confirmed many scientific theories, including the existence of dark matter and black holes, and have raised new questions that push us to keep exploring. Another recent achievement was the 14th anniversary of humans living aboard the International Space Station. Since the year 2000, NASA has maintained a continuous presence on the orbiting space station. It is a unique scientific platform that enables researchers from around the world to conduct innovative experiments not possible on the ground. The research conducted on board the space station has resulted in many benefits to human life, including medical advancements in chemotherapy drug delivery and vaccine development, as well as the use of optical imagery to assess and assist with disaster relief and improving coastal water quality. Astronauts aboard the ISS continue scientific research facilitating the journey to Mars, including exploring how crews can thrive on longer missions and testing new technologies. The most iconic images of space exploration include space-suited astronauts performing spacewalks, or, in NASA speak, extravehicular activities. In 2015, NASA is recognizing 50 years of extravehicular activity, celebrating past accomplishments and exploration while looking toward the future.
Hi everyone, and welcome to NASA's Marshall Space Flight Center in Huntsville, Alabama. My name is Sam, and I'm a Payload Communications Manager for the International Space Station. My job is to talk to our astronauts as they live and work in space. Today, I'm going to give you a super secret behind-the-scenes tour of our Payload Operation Integration Center, or POIC, which is our flight control room where we control most of the NASA science experiments on board the International Space Station. Control room, we have to be pretty quiet. As you can see, there are people in here working. The reason why is that we're here 24 hours a day, 7 days a week, supporting the science experiments that our astronaut crews work on. The front views up here in the front of the room show you how we monitor what the crew is working on. You can see internal views, external views, and normally we can see the astronauts. Right now you can't, and the reason why is because our crew is asleep. Just like you and me, the astronaut crews have 8-hour sleep periods every day to make sure they get their rest and are ready to go the next day. This console right here is my Paycom console, and this is where I actually talk to the astronauts. One of the coolest parts of my job is that I get to talk with NASA astronaut Scott Kelly and Russian cosmonaut Mikhail Kornienko, who are the 2 crew members of our 1-year mission crew. That means they're going to live in space for twice as long as all of our other astronauts do. The reason that they're up there is so that we can learn how the human body adapts to long-duration life without gravity. And this information that we get, the science we get back from this crew, is going to help prepare us to move on to Mars and beyond in the future.
The Curiosity rover landed on the surface of Mars on August 6, 2012. Unlike earlier rovers, Curiosity carries equipment to gather and process samples of rocks and soil, distributing them to onboard test chambers inside analytical instruments. Analysis of the first drilled sample provided the geological and mineralogical evidence of conditions favorable for life in Mars' early history. As the Curiosity rover continues to explore the surface, it will investigate further details on the past and current environments of Mars. NASA is also building a new human spacecraft that will usher in a new era of space exploration. Drawing from more than 50 years of spaceflight research and development, the Orion spacecraft is designed to meet the evolving needs of our nation's deep space exploration program for decades to come. It will be the safest, most advanced spacecraft ever built, and it will be flexible and capable enough to take us to a variety of destinations, including Mars. In December 2014, Orion completed its first successful flight test, yielding millions of elements of data to provide unique insight into how to improve the spacecraft's design so that it can safely send astronauts to Mars and back.
Hey everybody, my name is Matt Pruitt, and I'm a manufacturing engineer here at NASA's Marshall Space Flight Center. Today, we're going to take a look at a very important piece of hardware. You guys are probably familiar with the Orion spacecraft. The Orion spacecraft is what NASA's going to use to send men and women into outer space for exploration missions. Well, here at NASA Marshall, we have the heat shield from that spacecraft that flew back in December of 2014, the EFT-1 mission. We've had the heat shield for about a month here in our 7-axis milling machine facility, and you can see the 7-axis milling machine there. It's the very tall blue structure, and it's capable of removing very small amounts of materials very precisely, and that was very important for a piece of hardware that's as important as the heat shield, you can see here. So the heat shield during re-entry was exposed to about 4,000 degrees Fahrenheit, and that was as the atmosphere was rushing around the heat shield. It got very hot, and protecting the crew and hardware of the space capsule from the heat of re-entry is very important, and that's what this piece of hardware did. That's why you see the black coloration at different locations on the heat shield. The reason you don't see it everywhere is because we're about halfway done with the job of removing this material and preparing these samples, which is what the squares and rectangles are, for testing out at NASA Ames and NASA Johnson, which are 2 other NASA centers. They'll be performing thermal and structural tests of this material to see whether or not it's in fact the best material for the job.
Carrying the Orion capsule to space will be NASA's Space Launch System, or SLS, an advanced launch vehicle that will be the most powerful rocket in history. The SLS is a deep space vehicle capable of extending our reach into the solar system. With unrivaled life and cargo capacity, NASA will launch people and payloads farther into space than ever before.
Hi, my name is Peter Ma, and this is the Space Launch System rocket. One of my responsibilities with NASA is the mass properties engineer of the core stage, which is this segment right here of the launch vehicle. It's important that we understand the mass properties of the rocket in order to ensure that it sits safely on the launch pad as well as flying into orbit. Once we have the design of the rocket well defined, then we use advanced and rare manufacturing tools like the robotic weld tool to bring the components into shape. Right now we're at the Marshall Welding and Manufacturing Center, and we're about to enter the high bay, where we keep some of our weld tools as well as some other neat hardware. Let's have a look. So what we have here is the robotic weld tool. One of the neat capabilities of this tool is its ability to mold and shape itself around the hardware that it is manufacturing for welding. This allows NASA to make schedule and cost savings prior to and during manufacturing flight hardware. Now this is the vertical weld tool. We bring barrel sections here where it is welded into a complete assembly. Unlike traditional heat welding that you may be familiar with, we use friction stir welding. Now the difference with friction stir welding is we use shear pressure and force to join the bonds together to create something that's much stronger and more reliable for space use. It's tools like these that are incredibly important in our construction of the SLS rocket as we pursue our journey to Mars.
NASA's journey to Mars seeks to answer some of humanity's fundamental questions about life beyond Earth. Was Mars home to microbial life? Is it today? What can it teach us about life on Earth or life elsewhere in the cosmos? Could it be a safe home for humans one day? Right now, robotic scientific explorers are paving the way, and humans are preparing for the first human expedition to Mars. Robotic and human exploration of Mars will enable new scientific discoveries and create new frontiers in the exploration of our solar system.